Hello and welcome to this NCFE provider session on error analysis and misconceptions. My name is Charmaine Phelps and I'm the Curriculum Officer for Functional Skills, Maths and ICT, and also the new Essential Digital Skills qualification. My role is to support centres through the planning, onboarding and CPD process for NCFE cash qualifications, focusing specifically on Maths and ICT functional skills and Essential Digital Skills. If you would like the slides that accompany this recording, please send me an email at charmainephelps@ncfe.org.uk. The objective of this session is to explore strategies to identify and overcome misconceptions by analysis of errors. First, we'll look briefly at general misconceptions about maths as a subject that can hinder learner engagement. We'll look at the difference between mistakes and misconceptions, using formative assessment to diagnose and identify misconceptions, strategies to investigate misconceptions, which is strongly linked to overcoming misconceptions. I'll share resources and references to studies on this subject that have informed this session, and then end with a short summary. So first we'll take a look at general misconceptions. There are many general issues that prevent learners from engaging with maths, and a previous CPD webinar that you'll find on our YouTube playlist on engaging learners with maths explores these in more detail. I've placed a link to our YouTube playlist on a later slide. However, there are some general misconceptions that can hinder learning that we shall review here. You may find it useful to explore these in more detail from the 2018 Danish report referenced here. Mathematics is a set of disconnected procedures. In the study, a learner was identified who believed maths was a subject consisting of an incomprehensible swarm of weird and incoherent mnemonic rules that make no sense. Maths counsellors designed interventions making it clear to him that mathematics is a discipline of reasoning rather than of rote learning. The intervention was a success as the learner experienced that he was actually able to do mathematics, not just memorize it, and perform reasoning and carry out deductions of his own. Moreover, the things that he had to do made sense to him. There is only one way to solve a problem, and the answers are either right or wrong. Since maths is a logical and connected subject, there are often different ways to approach a problem. And as is discussed in the Approaching Assessment CPD session, a learner following a sensible, logical process to solve a problem can be awarded marks even if the answer they come up with is not actually correct. When learners understand that their functional skills maths is primarily about solving problems rather than simply knowledge of underpinning skills, they can begin to see how studying the qualification will help them in problem-solving tasks that they may be faced with in their work or study that doesn't even involve maths. If you struggle with a concept, practice similar exercises until you get them right. This is a dangerous misconception, and it can lead to learners being assessed as ready to complete their functional skills assessments, as it seems that after a period of doing similar exercises, they've proven they've mastered a topic, when in truth, they may not have understood what they're doing and how this underpinning skill can be used. This means that if they're presented with a problem that uses the same underpinning skills that they've learned, but set in a different context, they cannot see how to solve the problem. Completing repeated exercises on worksheets can certainly help with automation of processes and is a necessary part of learning. However, that alone does not lead to a deeper understanding of concepts to allow for connections to be made and more difficult contextualized or real-life problems to be solved. Now I'll take a look at mistakes versus misconceptions. The Education Endowment Foundation defines a misconception as an understanding that leads to a systematic pattern of errors. Mistakes are different to misconceptions and are more easily remedied. With a mistake, it may be that the underpinning skills and reasoning are sound. However, a slip of the mind, calculator error, or forgetfulness has caused an incorrect answer. To show the difference, we'll take a look at some examples now. So for each example, we'll take a look at two answers. They're both incorrect answers. However, one learner has made a mistake and one learner seems to have a misconception. Here, the problem is quite straightforward. It's simply to calculate the area of a shape. I'll reveal the two answers now, and you might like to pause the recording to take a look at the answers and decide for yourself which one is the mistake and which one is the misconception. Learner A has simply multiplied the values that they can see. So they must have an understanding that finding area involves doing a multiplication. However, they've not understood what that means. If they sense check their answer, then they would see that a rectangle that was 3 meters by 2.5 meters would have an area of 7.5 meters squared. However, that wouldn't account for the triangular part, clearly meaning that their answer should be less than 7.5 meters squares. Obviously, this learner needs to know how to calculate the area of a triangle and needs to know how to break up a composite shape and work out the necessary height, width, and length to solve the problem. But they might need to go a step further back and look at shapes on square paper to see how the formulas for areas of shapes have come about. It's not enough to simply know the formula for area of a triangle and area of a rectangle. Learners need to understand how these formulas have come into being so they can use them when presented with problems that are less straightforward. Learner B has simply made a mistake in adding together the 3 and the 2.5 to reach 4.25. It could be worth exploring, but it's highly likely that it's just a slip of the mind rather than an underlying misconception. We'll look at this conversion problem to convert kilometers into miles. Again, I'll show you two responses, which both have incorrect answers. One is a mistake and one is a misconception. So you can pause the recording to decide which is which. Learner B has a misconception. And in order to discover what this misconception is exactly, it'd be worth investigating with the learner. We'll explore diagnosing and investigating misconceptions in the next sections. But again, a simple sense check would show that if a mile is more than 1 kilometre, then 14 kilometres in miles should lead to an answer less than 14. Learner A has followed a logical process, even if it's not the fastest way to solve the problem, as they could have simply done 14 divided by 1.609, but their answer is incorrect, as they seem to have put in, when they've done the calculation, so they've gone all right here, but I think what they've done is they've put in 1 divided by 1.69 in their calculators to get the 0.59 miles rather than 0.62 miles. So again, it is worth exploring to ensure it's simply a calculator error rather than a misunderstanding of place value to ignore the 0. Combined probabilities seem to be an area of concern for many, so we'll take a look at the following question. So what's the probability that it will rain for 2 consecutive days in its simplest form? I'll give you a moment to decide which of these learners has a mistake and which one has a misconception. So learner A has correctly multiplied the probabilities for the 2 rainy days in a trot. So a quarter times 2/3, which would lead to the answer. Unfortunately, what they've forgotten to do is to give the answer in its simplest form. So 2/12 is correct, but the question does say in its simplest form, so it should have been a 1/6. Whereas learner B has added up the probabilities that lead to a rainy outcome. So they've chosen a quarter plus 2/3 plus 2/5 to give them 5/12. So clearly they're not comfortable with combined probabilities, but they also have an issue with adding fractions, as in order to add these fractions together, what they've done is they've added the numerators, 1 plus 2 plus 2 is 5, and they've added the denominators, 4 plus 3 plus 5 is 12, rather than finding the common denominator. So there's two misconceptions that you'd need to deal with there. We'll take a look at diagnosing misconceptions. Maths knowledge can be visualized as a wall, with the foundation layer being the basics of number, and then as new topics are covered, they build on this. If learners do not have a solid foundation and parts of the wall are missing, then it can mean that learners do not have a stable wall of knowledge, and the whole thing can end up tumbling down. As in the example before, when it comes to looking at combined probability, if learners don't have a sound grasp of fractions, they're certainly going to find it difficult to solve problems that involve fractions later on. It's your role as the tutor to identify where the missing bricks are and fill in gaps so that the wall is sound before progressing onto the next layer of bricks. Formative assessment will help you in identifying your learners' understanding as you progress through the qualification. Formative assessment can be defined as a method of assessing pupils while learning is happening, rather than at the end of a topic or sequence of lessons. It's contextualized and aims to build a comprehensive picture of learners' characteristics. It is an integral part of a learning process, and it takes place several times during a course rather than only at the end. Or put another way, formative assessments are for learning, while summative assessments are of learning. Or as assessment expert Paul Black put it, when the cook tastes the soup, that's formative assessment. When the customer tastes the soup, that's summative assessment. On the next slide is a list of different formative assessment methods and some online tools that can help with this. But you might find it useful to pause the recording here and decide or list the types of formative assessment methods that you currently use. So this slide has many different forms of formative assessments that you can use. Craig Barton is a big fan of low stakes quizzes. This slide has many different forms of formative assessments that you can use. Craig Barton is a big fan of low stakes quizzes. A quiz sounds more fun than a test, and if completed regularly and often, they can help to diagnose issues without making your learners feel under pressure of a test with results being shared. Tests, quizzes, low stakes, multiple choice. This slide has many different forms of formative assessments that you can use. So first, we've got tests, quizzes, low stakes, multiple choice, short and extended answer questions. Craig Barton is a big fan of low stakes quizzes. A quiz sounds more fun than a test, and if completed regular and often, they can help to diagnose issues without making your learners feel under pressure of a test or sharing results. Next, discussions. These can be formal or informal. It's important that the right classroom atmosphere is set up so that learners feel supported in analysing their thought processes in order for this to be effective. Similarly, for debates or justification activities. Self and peer assessment activities are useful for getting learners to spot their own errors or make sense of their peers' errors. This can be beneficial if you have a supportive and positive classroom environment. many learners will feel more comfortable spotting their own errors rather than having somebody else point them out. Card sorting activities can be useful. Presentations can be used to promote collaborative learning. Projects or scenario-based tasks, practical activities. These are especially useful when underpinning skills have been mastered and learners can then put their new skills into practice with questions or practical activities that are true to life and the assessments that they'll face. Questioning. Asking questions can help your learners to justify and potentially reconsider the logic that they follow to solve problems. Open questions can lead to a deeper understanding than closed or yes/no questions. For online or interactive formative assessment methods, there's a list here of some online tools that can all aid with formative assessment, either for remote learning or in the classroom or as a homework. Please note these are not NCFE endorsed, they're simply resources that myself and colleagues have found useful in our practice. For a recent CPD session that was looking at supporting learners with English as an additional language, I adapted a resource from the skills workshop that I'll link to in a later slide that can help all of your learners to ensure that they understand the terms. For a recent CPD session supporting learners with English as an additional language, I adapted a resource from the skills workshop that I have a link to in a later slide that can help to ensure all of your learners understand the terms that they're using. In John Holt's 1964 book, How Children Fail, he stated that he feels he understands something if he can do some at least of the following. State it in my own words, give examples of it, recognize it in various guises and circumstances, see connections between it and other facts or ideas, make use of it in various ways, foresee some of its consequences, and state its opposite or converse. This list is only the beginning, but it can help in the future to find out what our students really know, as opposed to what they can give the appearance of knowing, their real learning, as opposed to their apparent learning. So as an example, I've popped this resource here, and if you would like a copy of this resource, then please you can drop me an email for it. Now we'll take a look at investigating misconceptions. Before beginning a topic, it's useful to investigate the common misconceptions that learners have, and finding ways to investigate these can be a way to overcome them with your learners. We'll take a look at some ideas for how you might do this now. Concept cartoons are a visual way of exploring misconceptions in a way that doesn't embarrass learners who may share the same misconceptions. This is an example of a concept cartoon that you may find useful. So here we have Jamie goes for pizza with two friends. They share a pizza cut into 8 slices. Jamie has 2 slices and the friends have 3 slices each. How much pizza did Jamie have expressed as a decimal? And here Paul says 2/8 of the pizza, so that's 0.28 as a decimal. A quarter of the pizza, so 0.4. Aaron says 0.25 of the pizza. 2/8 of the pizza, so 2.8, says Mandeep. And then here, what do you think? This can obviously then lead on to discussion with your learners about which one of these, if any of them, are correct, 0.25 of the pizza. And you may like to consider other concepts that you could turn into concept cartoons in this way. When devising a concept cartoon, it's useful to give a few examples that are typical of misconceptions that you would expect. So, for instance, here, Aaron's got the correct answer. Steph understands that Jamie has had a quarter of the pizza, but is not able to express this as a decimal. And Paul and Mandeep may be struggling with simplifying fractions as well as converting fractions into decimals. True, false, sometimes activities are a good way to open up a debate with a group, or can also be completed independently. So if we take a look at this statement, so when you multiply by 10, you add a 0 to the end of the number. Is this true, false, or sometimes? I think this because this is actually a very useful one to consider, as it can help with you as a tutor thinking about how teaching shortcuts can actually lead to misconceptions. So yes, if it is a whole number and you multiply by 10, yes, then you do put a 0 on the end. But if you had 25.2 and you added a 0 to the end to make it 25.20, that does not multiply the number by 10. So it would be sometimes here. And again, you can easily see that you might have a learner saying, this is true. I think this because Mr. Dodds told me last year. Here's another statement. So if you reverse the number in a multiplication sum, the answer will still be the same. For instance, 17 times 33 is the same as 33 times 17. Is this true, false, or sometimes? I think this because. And again, this is obviously this one is true, and it's a really useful true fact for your learners to know that no matter how which order they do a multiplication, it does give the same answer, the same as with an addition. It doesn't matter which way round you do it, it gives the same answer. The same cannot be said, however, for division and subtraction. So an activity like this could lead on to looking at BIDMAS and how these the order of different calculations can make a difference and in what instances. Balloon debate or odd one out activities. So these can be quite useful so for this activity, you've got the list of statements here and you would need to cross them off one by one. So a ratio that's the same as 2 to 5 is here, a ratio the same as 33 to 12, a ratio the same as 4 to 8 to 24, a ratio the same as 4 to 12, a ratio the same as 40 to 25, a ratio the same as 3 to 16, a ratio the same as 14 to 49 to 63, and a ratio the same as 12 to 18. So the odd one out is the 3 to 1, which isn't given there. So it's quite an interesting way of doing an activity, and you can also use it to identify misconceptions of how your learners understand ratios, particularly since the 1 to 3 could easily have been crossed off there with the 3 to 1 if learners didn't understand that the ratio has to be in the same order. Counter examples. Presenting learners with common misconceptions can be a way to kickstart an investigation to determine whether the statement is true, or it can open up a discussion with your learners. So I'll present 4 different statements, and if you'd like to pause the recording after each one and try and think about how you might use this as an investigation with your learners, or as how you might use this as a starter. So larger shapes have larger perimeters. A simple investigation could be to give learners 12 1-centimeter squares of paper and ask them to arrange them to make different shapes and to record the perimeter. Obviously, the area is always going to stay the same if each shape is made up of the 12 1-centimeter squares of paper, but does the perimeter stay the same? Obviously not, but it's good for your learners to have the opportunity to see that for themselves. 3.2 hours is 3 hours and 20 minutes. You may present this perhaps alongside a statement to ask them to investigate, if that's the case, how many minutes are in 3.7 hours, 3.8 hours, 3.9 hours, etc. And allow them to work out how they could calculate for themselves what the correct number of minutes was before simply telling them that they could multiply the decimal by 60 or helping them to calculate 10% of an hour in minutes. It's always a good idea. Learners do tend to learn more by doing and thinking for themselves than by you simply telling them the quick way to solve a problem. 3% is 0.3 as a decimal. Again, this could be used as a starter to get learners thinking about what percent means and also what 0.3 means. So what is the place value of that 3? It's 3/10. So here we can see 3/10. What would 0.03 be as a percentage? So you can get learners to think about it. Another common misconception is 7 squared is 14. If learners haven't seen indices before, then it's a very easy assumption to make that it's just 7 times 2. And again, this could be a starter activity to begin a discussion around indices. It might be that one of your learners does understand what this means. How do they know this? What's their experience of it? Use other learners' knowledge to share with the group. Okay, we'll look at overcoming misconceptions. Now, much of what we've covered in investigating misconceptions will help your learners to overcome them. However, we will look at some alternatives next. We'll take a look at some strategies for overcoming misconceptions as an overview before looking at an online resource that can help to identify misconceptions likely to arise, as well as setting multiple choice questions to help identify misconceptions. Back to basics. If your learners are struggling with a concept, as it turns out there is a misconception present, then it can help to go back to the prior learning that is required to master the concept and review it in more detail. For instance, a great deal of work involving fractions, decimals, and percentages requires knowledge of times tables. So going back to reviewing times tables can be helpful. The example that we looked at previously of the area of a compound shape could be remedied by going back to drawing shapes on squared paper and counting up the squares. Plan ahead and collaborate. Working with other teachers to explore the way that shortcuts and misuse of language in earlier stages of learning can lead to misconceptions later on can help to ensure that such misconceptions do not arise. For instance, teaching how to multiply or divide by multiples of 10 by adding or subtracting zeros to the end of numbers rather than shifting the numbers to the right to divide or to the left for multiplying. Use practical examples. Using practical examples, counters, marbles, physical objects can help learners to understand what they're doing rather than simply following rules they can manage to get answers correct in a worksheet, but then end up struggling to use when faced with contextualized problems. So as an example, when it comes to combined probabilities, noting down all the possible outcomes of an event occurring and then calculating the probability can help learners to understand the shortcut of multiplying fractions, decimals, or percentages to achieve the same result. Make good use of multiple choice questions. Carefully designed multiple choice questions with the incorrect options uncovering common misconceptions can be a powerful diagnostic tool as well as an effective prompt for classroom discussions. Why do you think someone might think the answer is B? Discuss in pairs, etc. It can take time to create your own useful, well thought out multiple choice questions, but Craig Barton's Diagnostic Questions site has ready-made questions and quizzes that you can set your learners or use to inform your teaching or form the basis for discussions. I'll take you through how to use the Diagnostic Questions site now. So when you go to the Diagnostic Questions website, you can search for either questions or quizzes. Here we're looking for a quiz. You can then search by subject. So here we would click on maths. And then within that, you can then search by topic and then filter it down until you come to a specific topic. So for instance, here we've got equivalent fractions. Then it will open up lots of quizzes that are all about equivalent fractions, for instance. So I've selected a quiz here on equivalent fractions, misconceptions. And before I decide if I'd like to assign it to a class, I can first of all click on the insights. So clicking on the insights gives me a broad overview of how every learner who's previously completed this quiz has done. So the green shows the correct answers for each question. So for question 5, that must have been very tricky. Not very many learners got that correct. It was much higher proportion got that question wrong. And whereas, say for instance, I don't know, question 2 has a higher proportion of learners getting that right than wrong. So it will be interesting to see. You can then go into each individual question. So here is one of the questions. And for this particular question, I can look at the question. I can see how many learners have selected each answer, how many learners have got it correct, shown as green. And the author has put a very nice explanation of why learners may have chosen each option. So B is the correct answer. So A, B, and D are all equivalent to 2/3. So you can see that. So 2/3. So this one is just multiply top and bottom by 8. So it gives the same. This one is just multiplying top and bottom by 3. So that's equivalent. And this one is multiplying top and bottom by 4. So that's an equivalent fraction. Whereas this one, 2/8, is not. It's not an equivalent fraction to the others. With answer A, the student may have presumed they're equivalent because all of the numbers are even. So they've just come up with a random way of deciding whether they're even. If they chose answer C, the student just may have missed B as a correct answer. So they just may not have noticed it. And then learners who selected D, it's possible that the student may be looking for identical fractions. Obviously, you won't know exactly, if this is true for your learners, if they selected an incorrect answer, apart from the fact that brilliantly, if you make sure that when your learners complete a question, it also says reason. So for every single question in diagnostic questions, your learners are given the opportunity to write down the reasons that they have chosen the particular option. So for this particular one, we've got, these are all people who've chosen C. It's all completely anonymous. So this one got it because 12 and 12 is 24 and 8 and 8 is 16. So if we look, what was option C? So A and D. So they've worked out that way, but they've missed one. A and D, because half of 16 is 8, so that's the numerator, and half of 24 is 12, so that's the denominator. C, I think it's because B and C are not equivalent to any of them. C, I did the elimination progress because 8 divided by 12 times 2 is 16 over 24. So if we go back, so it does seem, they've all written it in a different way, but for nearly everybody who selected C, it is just because they've missed out B as a correct answer. So the great thing with diagnostic questions is that for each question, learners can state their reasoning behind why they selected their answer, which gives you insight into their reasoning and can help you to uncover your own learners' misconceptions, but you can also use this to inform your planning and also as a way to open up discussions with your learners. All the answers shown in Insights are anonymous, so learners don't need to worry about being identified by others when they submit their reasoning. However, you can see your individual learners' reasoning when you assign the questions and then check on the answers. And finally, we'll take a look at some resources, and this page has useful links where you'll find further examples of some of the strategies that we've explored. If you would like further reading for your own continuing professional development, then I have listed the references that I've used in creating this session that you may like to visit. Obviously, you can pause the recording and write them down. Alternatively, if you just drop me an email, I'll send you the slides and you won't need to note down such long link addresses. In summary, there is a big difference between a mistake and a misconception. We all make mistakes, and these can easily be highlighted and put right, whereas a misconception needs to be more fully explored. A positive classroom environment where learners are comfortable to ask for support when they need it and discuss ideas without fear of ridicule can allow for the type of dialogue and discussion that makes it easier to identify and overcome misconceptions. Exploring potential misconceptions before they arise and planning for uniform teaching across your department, as well as dealing with misconceptions when they arise, can help you to identify misconceptions and understand your learners' thought processes. Once you have an understanding of your learners' reasoning, you can then fill in any gaps in knowledge and use discussions, projects, etc., that bring your learners to a new understanding and enable them to use their underpinning skills along with their own common sense and make connections that will help them in their work and studies and enable them to tackle the types of questions that they'll face in their assessments. Upcoming CPD that we have for the remainder of this year is shown on this slide. We also have our YouTube playlist here. All of the live webinars can be booked through this link, and our YouTube playlist is linked here. Here are the key contacts. If you need individual support for training and development, you have access to the curriculum team. If you'd like to discuss additional qualifications, then each centre has a dedicated account manager, although if you don't know who that is, you can contact anybody from the business development team. When it comes to registering learners and uploading results or help with the Surpass online platform, then our customer support team can help with your queries. I do hope you found this session helpful. Thank you so much for your time, and from everybody at NCFE, please do stay safe and take care. Thank you.